All right. So, greetings, scholars. Let's see. So, I have that as that time. Watching the clock, we're in here. Um, Again, it should be the same settings each time. So, let me see. As far as announcements go, just try to make sure that people are not hanging out in there too long. Um, no major announcements. Okay, so we're a little bit ahead of schedule. We only have one chapter remaining, so I think what I'm going to do is just go ahead and try to finish as far as the new content is concerned. They should be able to get in. How is it that you all are able to get in? Is it like is somebody letting you in, or are you able to let yourself in? Like I don't understand how some students are able to get in and then some are not. I would just like it to be uniform. That's all. I'll give it another minute. But so we're going to go ahead and move into our final section. I mean, final chapter. Let's see, come on, single page. Come on, why are you not working? Yeah, I don't know. It's like temperamental. It's okay though. All right. So we're going to be moving into chapter 12 with statistics, and we're going to start with section 12.1 on sampling, frequency distributions, and graphs. All right. Let's do. So in the previous chapter, we kind of introduced counting techniques, which seems trivial, but then we came across some pretty interesting examples, give or take. And then from counting, we had the fundamental counting principle, how to identify when we're using either permutation or combination, where permutations involve counting where the order is important. If we change the order, that's counted as something different versus combinations. If you change the order, that's counted as the same thing. So we have a bunch of repeats. So we remove the repeats by dividing by r factorial. So then once we kind of went over some examples on counting techniques, then one application was probability, right? And so probability is what the likelihood that something's going to occur. Generally speaking, to calculate probability, we say the number of outcomes in our event over the total number of outcomes in the sample space, right? And so that's where the counting comes into play. So you have to count some of these weird little scenarios, and then so we can get a sense of the probability. Uh, how could I distinguish between probability and statistics? So probability is like the likelihood that something's going to occur, and then stats just kind of give you. It really just synthesizes data, right? I mean, probability is it kind of parallels it, but the stats are just like given a collection of data. What does this mean about a system? That's a oversimplification. At the risk of oversimplifying. Also, as far as notifications or updates, not really an update, just a reminder. When it comes to our assignments, remember we get unlimited attempts, right? So you don't have to ask for like an extension or anything like that because it's kind of already built into the structure, right? Really, those assignments are just sitting there waiting until you submit them, right? And then with unlimited attempts, the system is set to take your highest score. I personally am fine if you wanted to take this content that's on my open math and sit down with a tutor or a classmate and work on it side by side, line by line. I'm totally fine with that, right? Um, so just trying to remove some kind of like ambiguity, so I'm clear, right? Again, unlimited attempts is the information is really just sitting there waiting for you. Now, if you want like some additional practice, I do have an alternative resource. Like when it comes to online management, I actually prefer my math lab, and so maybe I can like make those assignments available, and you can do like a free trial, and you can just kind of keep making free accounts to keep the free trial going just for practice. So if anybody wants access to that, just let me know, and I'll set it up for you. Um, but it's a really powerful tool. It comes with a digital ebook. It pretty much comes with an explanation attached to each question. I don't know that that's available on My Open Math. I think the strong suit of My Open Math is that it's free. But as far as like functionality, I hands down prefer my math lab. It's just that if we were to like officially adopt my math lab, it does cost like about $120 per person, right? So free versus 120. But again, you tend to get what you pay for, right? So if it's free, the quality is like drastically reduced versus, yeah, you have to come out of pocket up front, but then the support is much higher, right? I'll just let them in. I think, let me see. See if people can get in. Okay, I'll just let them in. But anyway, that's all. You know, that doesn't really. You don't have to worry about that. Okay, so we're just gonna take our time and try to touch on like either no more than two sections per meeting, and then once we kind of finish this chapter, we can start kind of like reviewing like assignments and anything that's on my open math. Okay. So again, with 12.1, again, we're moving into statistics. And so we have section 12.1, sampling frequency distributions and graphs. A few objectives here. One, describe the population whose properties are to be analyzed. Two, select an appropriate sampling technique. Three, organize and present data. Four, identify deceptions in visual displays of data. Okay. So statistics is a method of collecting, organizing, analyzing, and interpreting data, as well as drawing conclusions based on the data. Methodology is divided into two main areas: descriptive statistics, collecting, organizing, summarizing, and presenting data, and then inferential statistics, making generalizations about and drawing conclusions from the data collected, right? Okay. That's kind of similar to the overview I gave when we started. So we have populations and samples. A population, a set containing all the people or objects whose properties are to be described and analyzed by the data collector, right? So that's the collection of all right? All the people or objects whose property are to be described and analyzed by the data collector. A sample is a subset or subgroup of the population. Representative sample, a sample that exhibits characteristics typical of those possessed by the target population. Okay, let's just keep going. Testing. Yeah, looks good. All right. So let's see, we have this example on populations and samples. A group of hotel owners in a large city decided to conduct a survey among citizens of the city to discover their opinions about casino gambling. Describe the population. Let me see. A group of hotel owners in a large city decided to conduct a survey among citizens of the city to discover their opinions about casino gambling. Okay. So it seems like it should be the citizens of the city. Let's see, because that's who they're serving. Let me see. Let's go with that. The population is a set of all the citizens of the city. Okay, let's go on to the next part. One of the hotel owners suggests obtaining a sample by surveying all the people at 6 of the largest nightclubs in the city on a Saturday night. Each person will be asked to express his or her opinion on casino gambling. Does this seem like a good idea? So we want a sample that's representative of all the citizens of the city, but they're going to the nightclubs, right? So then what about the people that don't go to the nightclubs? How many of the citizens go to the nightclubs? Are the nightclub goers representative of the citizens of the city? Do you have do most of the citizens go to the nightclub, or do most of the citizens do other things, right? So this does not sound like a good idea because it might not be representative of our population, right? Subset, or kind of targeted or biased, right? People that go to nightclubs might be biased. They might you know be biased towards casinos, right? So that could be misleading or manipulative. Questioning people at 6 of the city's largest nightclubs is a terrible idea. The nightclub subset is probably more likely to have a positive attitude toward casino gambling than the population of all the city's citizens, right? Okay, that makes sense. A random sample is a sample obtained in such a way that every element in the population has an equal chance of being selected for the sample. Methodology: identify each element in the population. Okay. Assign numbers to each element in the population. randomly select numbers, assign the elements in the population who have those numbers to the sample set. Okay. All right. So this is how we conduct a random sample. We identify the elements in the population, and then we give each element a number. Then we randomly select numbers, and we pull those elements with the corresponding numbers. Okay. So that's called a random sample. Which of the following is the best way to select a random sample to find out how the city's citizens feel about casino gambling? Randomly survey people who live in the oceanfront condominiums in the city. So now we're limiting ourselves to oceanfront people. What if the ocean, that's obviously not the best, because, you want something that's indicative of everybody, not just this region over here, right? So I would say this is not the best. Many hotels lie along the oceanfront, and these people might object to the increased traffic and noise which may result. It also does not give each citizen of the city an equal chance. Okay, so that's not a good idea. Survey the first 200 people whose name appear in the city's telephone directory. No. Randomly select neighborhoods of the city, and then randomly survey people within the selected neighborhood. Yeah, that's actually, what is that called? Is that a random sample? I think it has another name, but yeah, C is appropriate, right? You have you identify all the neighborhoods of the city, and then randomly survey people within the selected neighborhoods. Okay, let me see. And so B is just no, right? It does not give each citizen in the city an equal chance. Yes, this gives each citizen in the city an equal chance, right? So then, okay, let's keep going. So construct a frequency distribution for the data of the age of maximum yearly growth. I feel like we're missing something. I guess we're okay. Construct a frequency distribution for the data of the age of maximum yearly growth for 35 boys. Okay, so we have 35, which is what? 1, 2, 3, 4, 5, 3, 6, 7. Okay. Frequency distribution. So when we're constructing a frequency distribution, what it is that, okay, we have this data and we want to see what's the frequency of each entry? How often does each entry occur? So we're going to basically do a set of tally marks. It kind of helps if we can identify the max value and the min value. Can anybody tell me, like, identify either the maximum value and or the minimum value? Because like I'm seeing 10, right? 10 is a potential minimum. Let me see. So we see this 10. What about a max? I see 16, 17, 18. I don't see anything higher than 18 and lower than 10. Okay. So for our table, we'll do the growth versus the frequency, how often each of those outcomes occurred. Okay. And it looks like we're going from 10 to 18. So I think I'm gonna just list all the entries from 10 to 18. So we got 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay. Then we want to do a tick mark every time one of those occurs. Okay. So we have a 12. This should be okay. Okay. So I'm just going to cross that off so we don't count it twice. 14, 13, 14, 16, 14, two more 14s. So 1, 2, 17, 13, 10, 13, 18, 12, 15 is here, 14, so we're at 5, 2 more 15s, so then 1 and 2, 2 more 14s, 1 and 2, 13, 15, 16, 15, okay, 12. What's this, Bob Ross? I think I need to watch. I don't even know if they're still available. I feel like that painter, though. He's like, with the big fro, he's like, okay, we're going to paint a little tree right here. Yeah, that's a happy tree. But I have my hesitation in saying that because I think there might be some like dark controversy around him. I never watched whatever presentation they had on Netflix about him, but I think it was like steeped in darkness. Like I don't know if it was like a murderer or something like that. I don't know. I'm not trying to slander his name or anything, but I don't even know if that presentation is still available on Netflix. Then 16, okay, 11, 15. Okay, I'm just trying not to miss one. 12, 13, here, 12, 11, 13, and then two more 14s. Here, okay. Okay, so what I'm gonna do, I'm just gonna move this over a little bit so I can just write the numbers, the frequencies. So 10, it looks like it occurred once. 11 occurred twice. 12 occurred 5 times. 13 occurred 7 times. 14 looks like it occurred 9 times. That one occurred 6, 3, 1, and 1. Okay. Okay. So our frequencies should add up to, I think we had a total of 35 entries, so these should add up to 35. 1 plus 2 is 3, plus 5 is 8, plus 7 is 15, plus 9 is 24, 33, 34, 35, right? So notice that these add up to 35. So that means that everything was accounted for, okay? So then now we can see, so then looking at this, we see that what? 14, let me see, the age of maximum yearly growth. So most boys had the max growth at age 14. There were nine boys that had that growth. So, you can anticipate that age is where there is most likely to have like a growth spurt, right? Because that had the highest frequency. Okay, let's see. I think I'm interpreting that properly. Okay. Okay, I think we're okay. So what are some of the conclusions we can draw from this example? Boys are most likely to have their growth spurt around age 14. Their maximum growth spurt around age 14. Maximum growth for most subjects occur between ages 12 and 15. Okay, the number of boys who attain their maximum yearly growth at a given age increases until the age of 14 and then decreases after that. That's really interesting. That's a mouthful. All right, that's fine. So here are the statistics test scores for a class of 40 students. Group the frequencies into classes that are meaningful for the data. I got to think about how do we used to do our classes. So maybe we can do these, since these are test scores, maybe we can do these by tens, like you have your, 90s, 80s, 70s, and 60s. Or maybe I'm going to glance, because that seems kind of broad to group them into group sets of 10. I feel like maybe sets of 5 might be a little bit better. I'm just going to kind of glance to see how large. Okay, so so it did look like they went by tens. Okay. Let's see if we can find the max and the min like we did before. I see a 94 for a maximum. Okay, let's go with the 94. And the minimum, I see a 50. I see a 43. Is there something lower than 43? Okay. Is there something higher than 94? Okay, I feel like this might be the max and the min. Okay. Okay, I was just thinking. Okay. So if we group these into sets of 10s, we can go what 40s to basically the 90s. I'm kind of short on space here, so I think I might have to get a copy. Okay, let's try it here. Hopefully I have enough space. We'll say the class versus the frequency. Okay, so then we have what 40 to 49, 50 to 59, 60 to 69, 70 to 79, 80 to 89, and 90 to 99. Okay, so every time a result falls in one of those classes, it gets a tick mark. Okay, so then 82 can go here. We'll cross it off. 47 is here. Cross it off. 75, 64, 57, 82, 63, 93, 76, 68 is here, 84, 54, 88, 77, 79, 80, 5, 94, 92, 94, 80, 94, 66 is here, 81 is here, 67, 75, 73, 66, 87, 76, 45, ooh, way over here, 43, 56, 57, 74, 50, 78, 71, 84, 59, and 76. Okay, 40 students. Okay. I'm a little bit short on space. It's about the most. Here, I can move it a little bit more. So I just kind of. Okay. So then we had what, 3 in the 40s. What is that? 6 in the 50s, 6 in the 60s, 5, 10, 11 in the 70s, 9 in the 80s, and 5 in the 90s. These should total 40. 6 and 3 is 9, plus 6 is 15. 15, 25, 26, 35, 40. All right, so these add up to 40. Okay. Okay, so that's not too terribly bad. Since the letter grades are given based on 10-point ranges, use these classes. That's fine. That makes sense. So the class 40 to 49 has 40 as their lower class limit and 49 as the upper. So the class width is 10. It's sometimes helpful to vary the width of the first or last class to allow. That's fine. to allow for items that fall above or below most data. 40, the sum of the frequencies is the number of data items. That's fine. And I think we got these results. That looks good. Okay. So then we have histograms and frequency polygons. A histogram is a bar graph with bars that touch, can be used to visually display the data. All right. Let me see. The boys' ages of maximum yearly growth. So we can take our frequency, our histogram, our frequency distribution, and convert it into a bar graph. We have those ages on the bottom, and then the number of boys that fall into those categories. Basically, their frequencies on the left, and then you can basically convert it into a bar graph. And then with that bar graph, we can convert it into a frequency polygon, where we're gonna identify the midpoint of each of those bars and then connect them with like a straight edge to make these different segments. And notice it starts at 0 and it returns back to 0. So it's a line graph formed by connecting the dots in the midpoint of each bar of the histogram. Okay, so a histogram is basically a bar graph. Our frequency distribution is what we were doing earlier. And then from the histogram or the bar graph, if you connect the midpoints with line segments, we get our frequency polygon. Okay, stem and leaf plots. So let me see. So this plot is constructed by separating each data into two parts: the stem consisting of the tens digits and the leaf consisting of the units digit. Stem and leaf plot. It's another form of like a histogram or a bar graph. It basically organizes the data so you can get a sense of where most of the outcomes lie. All right, let's see. So use the data below for a stem and leaf plot. Okay. I think we got enough space here. I'm going to kind of work on the side. Again, with these, it helps we can identify our max value and our min value. Let me see. I see a 45. I see a 43. Anything lower than 43? I see a 94. Is this the data we had earlier? I see a 94. Is there something higher than a 94? 3 94s. Anything lower than a 43? 4. Okay, I think that might capture our range. Okay. So we're basically going from the 40s to the 90s. Right. So the stem and leaf plot, let me think. So we're going 40s to 90s. So we'll say like 40. Let's back up. We can do like 40, 50, 60, 70, 80, 90. So that's our stem. And then the leaves are going to be our ones place. All right. So let's see how this evolves. 82, we're going to capture it like this. Just put a 2. So that means 82. 47, we put a 7 here. So that means 47. 75, we put a 5 here. So that means 75. 64. Right. So the units place counts as our leaves. 57. Okay. 82. So now we have two 82s. 63. Okay. 93. 76. So it can be a little bit tedious, I feel like part of the challenge of being a student is learning how to intrigue yourself enough to just get the job done. Even if it is boring and, meticulous and tedious or whatever, try to find something just to get you to engage and focus, right? That's actually a talent or a superpower, because it kind of gives you an edge over your peers, right? Like, I think I've shared this before, but like, oftentimes I'll have students like they'll get out of my class, they'll finish, and be like, finally done with math. I never have to do any math ever again in my life. Right. And then they graduate and then they go to apply for their first job. And the first thing they give them at this job interview is a math exam. I can't tell you how many times I've had students come back and say, yeah, Mr. Phifer, you were right. Right. I forgot why I brought that part up. Let me see. Give me a moment. We were doing the stem and leaves. I was going through. Oh, Okay, yeah, it gives you an edge over your classmates, right? So I don't really like this, but a way you can kind of do some alchemy energy or spin this experience of mathematics in your favor. You may or may not like math, but at least if you can do it, it sets you apart from your peers, right? If you have two people applying for a same job or doing a task, and they're kind of in competition, for this position, you know, if one of them is more proficient in math than the other, then that kind of gives that person an edge, right? Now, if it were up to me, I wouldn't make everybody study this kind of stuff, right? I don't really feel like it's for everybody, because it takes a special kind of person to like this stuff, right? In the sense of slowing things down, organizing the data and the information. That's not for everybody. Um, but like, if you're an engineer or a scientist or any kind of analyst, you actually need this stuff, right? These kind of topics are pervasive in like everything that we do. Like if you think about like who programs the streetlights, who decides that this is the best structure for these intersections, who decides that the layout of this land is the most economical, the most efficient. Well, sometimes obviously people do a poor job because now we have hella traffic or hella accidents, right? Or it's dangerous. Or like, do we need to incorporate a pedestrian bridge or some kind of bypass? Like, how could we make the roads more efficient? How could we make our telecommunications more efficient? How can we make our devices charge faster? How could we get like free energy? How could we, like all of these kind of questions involve using this kind of information and data. But again, that's not for everybody to slow down and actually start solving problems of society, right? Like, how can we feed the homeless? How can we house the homeless, right? Like, if you think about, I've seen where they have like massive 3D printers and they're able to 3D print houses. Like in disaster relief areas, they can 3D print houses in like a matter of hours. And like you can use them for like relief. Like if people need to be treated, they can have their own room and have some shelter. Um, I've seen it done. Don't get me started on free energy and that kind of stuff. But again, I just stumbled across it. Like it's not like I went looking for this. I just had a talent or ability for it, and so I just kept going with it. All right, but just because somebody might not be talented in mathematics, they're going to have talents that I ain't even think of. Either it might be like the gift of gab, or like communicating with people, or engaging people, or dancing, or who knows? They might even have something that I never just considered at all. So it's like, I'll finish with this quote and then get back on task. But like, I think this quote, there was a quote by Albert Einstein that says, um, if you judge a fish by its ability to climb a tree, it'll spend its entire life thinking it's dumb. Right? Where in reality, it's a genius. Right? If that you looking at this fish, it can't climb the tree. Oh, that fish is dumb. No, this fish is a genius. You just need to put it in the right environment, and then it can shine. Right? And I feel like that's how a lot of us are. So you know, I just say that to say I don't want anybody to feel bad about this if you're not getting it. You definitely are a genius because again, I only get certain type of people in my field. Um, you just the challenge that you have to do is how can you take your natural talents and abilities and spin them so that you can apply it to this just to get the job done, and then once you're done, just kind of cross the bridges as you get to them. You know what I mean? But again, as far as I'm concerned, everybody's a genius. You have your own talents and abilities. It may or may not be math. It could be something else. It could be drawing. It could be, you know, politics. It could be law. It could be engineering, medicine. It could be so many different things. Agriculture, architecture. The judicial system, enforcement. It's so many different things where you can shine, right? So again, if it were up to me, I would take each person, like, okay, what do you want to do? Like, if you had all the money and all the time in the world, what would you do with your time? And then whatever the answer is to that, now let's build something centered around that, something that you can do just for the sake of doing it, not for any kind of monetary gain, not for any kind of anything. It's just because that's what you want to do. No real reason other than that, right? I feel like the more we do that, the better off we'll have less instances of like anxiety, and all sorts of like chaos that we experience will be drastically reduced. And some Japanese cultures or Asian cultures, that's called like ikigai. I think I mentioned this once before. But there's like this procedure where you answer these series of questions and it helps to identify your life purpose, right? And then once you identify your life purpose and you start building around that, energy and everything just flows naturally. It's not, it's like, it's just a natural flow versus if you find yourself working a job that you hate, now you're using all of your energy to spend time at this place that you do not want to be, people that you don't want to be with. And then when you get off work, you don't have any energy for what you're working for the people you're working for the house or the home that you're working for. You don't have any energy for it. I don't believe in that at all. So, just trying to encourage people to like find their purpose, walk their life path. I think it's called Ikigai or something like that. Don't quote me on this stuff. I'm just sharing my experiences. You know, take it and leave it however you see fit. Okay. So enough of that. Back on task, right? So we're doing 68, right? So there's need to be an 8 by the 6. That means 68. 84 right here. Okay. 54 right here. 88 is here because we're going to have to go back and adjust these. 77 is here. I'm just organizing the data right now. 79, 80. Okay. 94. Oh, this one actually, I think they may have broken apart into doubles. Okay. I think we did the 94, right? We're going to go with this for now. I'm going to readjust this. 92, 94. 80. So it's another 80. Yeah. 94. 1, 2, 3. Wait a minute. 1, 2. I missed. No, I got it. 94. 66. 81. 67. 75. 73. 66. 87. 76. Yeah, I'm gonna break these apart. 45. 43. 56. Okay. 57. 74. 50. Okay. 78. 71. Ooh, I'm running out of space. 84. 59. And 76. Okay. Put a 6 there. I'm kind of out of space. I think I can generate some space. Okay. So that was what? 76 was the last one? Okay. So now usually with the stem and leaf plot, those leaves are in like ascending order. So you got to put them in order. And I think that so it's not so like skewed. I think it's broken into like multiple parts. So like you can do, I think that would be what? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So we're gonna break instead of doing it by tens, we're gonna do them by fives, where we do 0 through 4 and then 5 through 9. Let me just confirm that before I do it. Actually, I think what we have is fine. Okay, we should adjust this. I just want to kind of confirm before we do it. So in order to do the stem and leaf plot, right? First, we enter the datas in the first row. So we have our tens, right? And then continue with all the remaining rows. So we did all this. That's fine. Oh, that was it? Okay, maybe we were okay. Well, when I've seen it in another presentation, they arranged it so that those leaves were in ascending order, but I'm glad I checked it before I did it. So what we have is fine. That's okay. And so basically it kind of serves as like a mini bar graph. We see that we have most entries in the 70s, right? We have a 75, 76, 77, 79. Like you can see all your 70s here, right? And then the next highest entry are 80s, and the lowest are the 40s. Right. So the stem and leaf plot is just another way to organize the data. Right. And it's kind of like a mini bar graph. Okay. I'm glad I checked it before redoing it. Okay. So then deceptions and visual displays of data. All right. So story time. It's not really good or bad. It's just a random story. It's not really random. It's relevant to this. But when I was in grad school and my professor was introducing statistics, he was kind of talking about the manipulations or how deceptive statistics can be, right? Like for instance, he was like, suppose I don't know if I shared the story with you all or not, but I'm just going to share it now because it's this topic. But suppose there was like a marketing firm and they were making an ad for a disinfectant cleaner that they had. And so in their commercial or in their advertisement, it says, "Oh, kills 99.9%. Well, kills 99.99% of all germs." So then, as a consumer, if you were to see, "Oh, it kills 99.99% of the germs," you'd be like, "Oh, well, that's pretty much all of them. So I probably get this one, right?" But then, what it doesn't tell you that, let me see, there are what, trillions of germs, and so then 0.01% of a trillion is what, still more than a million. Let me see. Hey Google, what's 0.01% of 1 trillion?
The answer is 100 million.
Right. So 0.01% of a trillion is 100 million germs, which is still more than enough to do damage, if not be fatal. Right. So it's misleading, right? You're using this product, you think you're getting, oh, well, we've gotten enough of them. But in reality, it still leaves enough germs to cause damage. It's misleading. What was another one that he gave? That I wish I could remember that story because that one was trippy. I can't think of the other ones. That's the only one that's on the forefront of my brain. Mm. Yeah, he actually he did another one, and I'm totally butchering this one, but he did another presentation where he was talking about the guidance system for like a missile, right? And if it's off by like some small percent, then it could be catastrophic, leading to like, civilian casualties, like in excess. But I can't remember the nuances of that story. But it was involving this kind of thing, you know, stats and you know, um, errors and things like that. But I'm trying to think. There was another one, but I can't remember any of the other ones. So, but the disinfectant one actually made sense. Oh, okay. So another one is just another random story. Um, most people, if they were to lose 99% of their wealth, they would be in poverty, right? But people like Bill Gates, they could lose 99% of their wealth and still be a millionaire, which is, and probably even a billionaire, and still be like well off, right? They can lose majority of their wealth and still have a massive amount of money. That's just how much money these guys have, right? Hey Google, what's 1% of 1 trillion?
The answer is 10 billion.
Jeez, 1% of a trillion is 10 billion. Now I don't know. Oh, here, this is what I wanted to ask. Um, hey Google, what's Bill Gates' net worth?
The net worth of Bill Gates is $108,500,000,000.
Okay, 108 billion. Hey Google, what's 1% of 108 billion?
The answer is 1,080,000,000.
No, that's not right. Let's try that again. 108. Oh, wait, no, that is right. 108 billion is still a billion. Yeah, he can lose 99% of his worth and still be a billionaire. Or at least you could say millionaire, but yeah, he's still up there. He can lose most of his wealth and still be well off. All right. So, just trippy stats, right? Okay. So let's look at this. Deceptions and visual displays of data. Percentage of people in the United States living below the poverty level from 2001 to 2005. Okay, poverty rate. The U.S. poverty rate rapidly increases from 2001 to 2004. The graph in both figures present this data, right? So if we look at the graph on the left, notice there's a sharp increase in the poverty rate versus the way the data is displayed on the right. It looks like it's a gradual increase, right? It looks like it's slowly increasing, right? But it's based on how the data is displayed. It's like it's based on the zoom level, right? But both of these graphs are showing the same data. It's just displayed differently, right? So graph can be used to distort the underlying data. The graph on the left stretches the scale on the vertical axis and creates impressions of rapidly increasing poverty rate. The graph on the right compresses the scale on the vertical axis to create an impression of a slowly increasing poverty rate. Right. So if you are a marketer or you possibly even a lawyer, and you can choose which graph and just don't allude to like how it looks. Like just say, hey, it's just like if you wanted to. It depends on what you're going for, but that's part of the manipulation. Like that's part of it. That's part of like stats. Like it's really trippy and weird. Okay, we have a solid like 30 minutes. Let me see. I'm just trying to decide if I want to start the next section or not. Things to watch for in visual displays of data. Is there a title that explains what is being displayed? Are numbers lined up with tick marks on the vertical axis that clearly indicate the scale? Has the scale been varied to create a more or less dramatic impression than shown by the actual data? Do too many designs and cosmetic effects draw attention from or distort the data? Has the wrong impression been created about how the data are changing because equally spaced time intervals are not used on the horizontal axis? Furthermore, has a time interval been chosen that allows the data to be interpreted in various ways? Right. So I feel like I still feel like this example is apt. I guess I don't know if that's the right term or not, but it's relevant. Like in the sense that even though both of these are showing the same data, one gives a different impression over the other. Right. So you have to be aware of these deceptions, the Decepticons. 5, are bar sizes scaled proportionally in terms of the data they represent? 6, is there a source that indicates where the data in the display came from? Do the data come from an entire population or a sample? Was a random sample used? And if so, are there possible differences between what is displayed in the graph and what is occurring in the entire population? Who is presenting the visual data, and do they have a special case to make for or against the trend shown by the graph? Yo, I don't know about you all. I'm kind of geeking a little bit because, like, right before I got on the call with you all, I was watching a presentation by like Russell Brand. He's like a comedian slash activist actor kind of thing. Activist. I don't know, so weird. But so he's the one that introduced me to this app called Rumble, right? Because like on YouTube, it's basically censorship, right? It's infringing on our like freedom of speech. They were like, well, you can say what you want, just not on our platform. So it's censorship, right? And then like now, I mean, it's gotten so disgusting because they always say, oh, that's misinformation. But I'm like, well, who are you to decide what's misinformation? How do we know that the information that you're giving us is misinformation? Like, you have fact checkers. The real rigor. It's like rigor comes in having a discussion, right? You have one opinion or belief, and then you have an opposing opinion or belief. But if the opposing opinion or belief is shut down and it's all lopsided, then we can be fed anything, right? We can be fed all sorts of lies, and I feel like we're all adults, we're all intelligent, to some degree, right? Obviously, but allow people to decide for themselves, as long as but not allowing people to have a voice, because I mean, every time I think about it, it kind of gives me like weird chills in the sense that when Trump was running for office, he was saying all this kind of weird stuff, and even when he was in office, he was like, "Oh, we need a space force, and they have these space lasers," and he said some other stuff. And when he said it, it sounded bizarre. I was like, "This cool," I was like being really dismissive of him. Now in hindsight, especially after like Maui, just look up directed energy weapons, that stuff is there. Like a lot of that weird stuff that he was saying, I was like, dang, he did say that. I was like, dang, he did say that. Dang, he did say that about those emails. Those emails are nefarious. Like when you actually kind of get into what was in those emails and some other stuff, it's like, ooh, so like now I'm like, I don't know how to feel about him. But I still don't think he's the guy for the job. I think he's really powerful, but he does too many underhanded. I feel like if he were to get back in office, then it's like we'll be borderline like dictatorship. I don't know that we would ever have a true election ever again, right? But I don't know. I mean, but I think it's fair to allow people a space to voice their opinion, and then we got to go back and forth because those people that we dismiss oftentimes are saying like critical information that, like, if you actually dig and research and fact check and confirm yourself, you find that a lot of it's actually true. And then, wait a minute, if that's true and you follow the money and this means that, oh, they've been scamming us the whole time, yada yada yada, right? So I'm kind of feeling the air. If we can go, like, I guess we got about 10 minutes left. We'll work on this example. We'll see how long it takes. And then I think we just might call it a day. We finished a little bit early. Um, but yeah, but again, I'm geeking because, so Russell Brand on basically, so on Rumble, so on YouTube, basically you can't just speak freely. Like if you say things, and they'll bring your video down. You get banned, all this kind of stuff. So then on Rumble, the idea is that it's like YouTube, but you can say whatever you want, right? It's free. It's true free speech. So that's what I was actually watching before we met just now, and they were talking about like basically this myocarditis stuff, like with the heart palpitations in young people since the pandemic and all this other stuff. It's really interesting, and it's using this kind of stuff that we're talking about, the data, and then how is it that all of a sudden young people are now having all these heart troubles where before it wasn't there, now all of a sudden it's there, and then is there a connection or a correlation between all these mandates? And then it's like, if these mandates were unjust or like they caused like long-term permanent damage, there's going to be a crap ton of lawsuits, especially like with some of these schools and institutions. Like that's what they were saying. Like that's when I had to stop the video so I could come to this class. But I was like, yeah, they're making like valid points. Like I even I purposely chose remote because just to buy time. I didn't know what was going on. It didn't make sense to be in the presence of others. I was like, well, until we can get to the bottom, is this a true airborne virus? Is it something else? You know, it made more sense to me. The better to be safe than sorry. So I was like, well, I just would clamor for a remote whenever I can get my hands on it. I mean, if you want a good documentary to watch regarding all of this, another good one is called Watch the Water. That's a really good one too. Okay, let me try to wrap up this example. I'm the king of going on tangents, right? So let's like redirect our focus and finish this out, and we'll call it a day. Examples of misleading visual displays. So cosmetic effects of home. Let me see. Cosmetic effects of home with equal heights, but different frontal additions and shadow lengths make it impossible to tell if they proportionally depict the given areas. Time intervals on the horizontal axis are not uniform in size. What? Are we missing something? Making it appear that the dwelling swelling, what? Dwelling swelling has been linear from 1980 through 2010. Okay. The data indicate that this is not the case. There were a greater increase in area from 1980 to 1990, okay, averaging 34 square feet per year, then from 1990 to 2010. Okay, averaging approximately 15.6 square feet per year. The number of square feet in average U.S. homes is single-family houses. So this does imply it's like as time progresses, it's getting more. But this is saying the data indicate. Let me see. The intervals on the horizontal axis are not uniform in size. The first one went 10 years, 80 to 90, and then it goes what 20 years. So that's not uniform, making it appear that the dwelling size has been linear from 80 through 2010. The data indicate that this is not the case. There was a greater increase from 80s to 90s, averaging 34 square feet per year, then from 90 to 2010, averaging approximately 15.6 feet square feet per year. Interesting. Okay. Okay. So we went on a little bit of a ride there. Just interesting stuff. Like, and it's relevant, and it's like it's so sinister. Like it's so sinister. It's clear that there's like fear mongering going on. Prior to this, whatever it is that we experience, it would take like at least 5 years for scientists to come up with a vaccine. Now they're able to do it in like 3 months, and then force people. And like also in the past, it was always an option. Like, you always had the choice. Well, if you weren't comfortable with it, if you were uneasy about it, not a big deal. But now when they're like giving like incentivizing people taking this, I was like, why are they pushing this on people so hard? It was so weird. It was like it was giving me so many red flags. So, anywho, I feel like we're close enough to the end of class I'm comfortable with where I don't feel like I need to start the next section. Are there any burning questions before we go our separate ways? Going once, going twice. All right. And again, I'm not really an authority on the other stuff. I was just venting a little bit, but I tried to be like as PC as possible. Uh, I'll say that to say encourage you to like do your own research and decide for yourself when it comes to a lot of these things. Don't take my word for it. You have to dig, cross reference, check your sources, do your own research, and make a decision. But I definitely don't encourage I don't encourage like just take what an authority tells you at face value, right? Because they'll tell you anything, and then when things go sideways, they'll be like, "Oh, my bad," and then that's it. They won't. Are they going to be there to take care of you if things go sideways? Are you even going to be alive if things go sideways? You see what I'm saying? It's like, what are they going to do if they're wrong, right? So if they're not willing to, take care of me and mine forever when they're wrong, then they need to let me decide for myself, right? Okay. So, and again, on that note, if there aren't any burning questions, we're going to go ahead and end the session here. And from one beautiful mind to another, have a great weekend, beautiful people. I will see you next week, same time, same place on Tuesday. Take care.